Okay, this is the Unit 4 test, questions 11 through 14. And here we have a complex or compound fraction, and we have denominators of k squared and k throughout the exercise. And so a common technique is to multiply the major fraction, numerator and denominator, by all the denominators you see throughout the problem. And so in this situation, what we're going to do is multiply on the top by k squared and multiply on the bottom by k squared. So by doing that, you will be multiplying by 1. It won't change the value of the overall fraction. We're going to carry out a distributive property here. So it's going to be k squared times 1 over k squared. And it's going to be k squared times 1 over k. And when you carry that out, of course, you're going to have a 1 um, plus k. And that should make sense to you because 1 over k squared times k squared, the k squareds are going to cancel and you're going to be left with a 1 right there. 1 over k times k squared, one of the k's will cancel with one of the k's, leave you with a 1 plus k. Likewise, in the denominator, when we carry out this distributive property, um, pretty apparent that you're going to have k plus k squared, which would be fine, except you're not really complete, you're not finished, it's not really simplest form. That denominator, pretty apparent there, has a factor of k in it between all the terms. So if we factor out the k, we're left with 1 plus k, right? And the numerator is a 1 plus k. And because division and multiplication right here are inverse operations, the 1 plus k cancels with the 1 plus k. And so your final simplest form answer is 1 over k. All right. So that's question 11. Question 12 has had the most questions asked about it, and people have been um, wondering how to get this done. And so as you look at this question, it's an inequality. And as we've said quite a few times in these solutions for unit test 4, you want to think of it as equality, right? If you have trouble with these, then one thing you can do to kind of help yourself out is to ask yourself, instead of the inequality, think of it as equality. And then in this fraction, it's apparent that it will never equal 0, because the only way a fraction can equal 0 is if the numerator equals 0, right? Because we know we can't allow the denominator to equal 0. And since the numerator is a constant 3, you aren't going to have any solution to this, but you will have some numbers that you're concerned about. And of course, the concern is if that denominator, the x cubed minus 2x squared minus 7x minus 4, if that was to equal 0, right? That's cause for concern and could identify some points that we might be interested in. Um, Now, as a little hint, the coefficient of the x cubed is a 1. And if you compare the coefficients and the constant, we have a 1 and a 2 and a 4, and of course that totals 7, and we have a minus 7 here. Well, so if we allowed, just by inspection I'm doing this, so my clue was looking at these coefficients, right? And so if I had 1 times negative 1 cubed minus 2 times negative 1 squared minus 7 times negative 1 minus 4 equals 0, then you would get negative 1 minus 2 plus 7 minus 4 equals 0. And it would actually check. You would get 0 equals 0. So by inspection, I've discovered a root. Now there are other ways to examine polynomials and determine roots of the polynomial, and there's certain rules about um, the coefficients with regard to those roots and with regard to sign changes, but without getting into a whole long discussion of the fundamental theorem of arithmetic or Descartes' rule of signs, this is sort of not our focus here. Our focus is more to try to get you to um, examine expressions and see structure again. And so from there, what I'm going to do is realize that since negative 1 is a root of this thing if it was equal to 0, then in terms of factors, right, since negative 1 works, I know, see if this makes sense to you, that x plus 1 would be a factor of this thing if I was to factor it, right? If x equals minus 1 works, then x plus 1 has to be a factor. And all I'm doing is bringing the minus 1 over with the x and setting the thing to 0. Then from there, we could use synthetic division, we could use polynomial long division, but as we were doing earlier in this refresher program, I'm just going to try to get you to see this intuitively. If it factors, this term would have to be an x squared, right, to get the x cubed. And equally likely, the constant term down here is going to have to be a minus 4, because 1 times minus 4 would generate this constant minus 4. And so we know we're good on our first term, and we know we're good on our constant term. And if we just focus now, say, on the x squared, right here we've generated a 1x squared when we do the product of this factored form. We need negative 2x squared. Right now we have plus 1x squared. So what term can I load in the middle so that I'll end up with minus 2x squared? Well, this is 1x squared, and so I want a minus 3x. All right, and that will form the minus 2x squared. And as luck would have it, happily, if you look at the x combinations, right, if I just strip out those parentheses um, and just look at the x situation, I'm going to get right here a minus 3x, and in conjunction um, with that, I'm going to get, rather, let me just correct that, right here, I'm going to get a minus 3x, okay? And right here, I'm going to get a minus 4x. And minus 3x minus 4x is the minus 7x that we need. So that's intuitive factoring. You can work at it with polynomial long division um, or synthetic division, but certainly what you want to develop your ability to see structure. It will help you in the calculus. Now, we're not quite finished there because this factors further. Um, the x squared minus 3x minus 4 factors pretty easily. It's the stuff of high school elementary algebra. So it's going to be an x and an x, and we want a minus 4 and a minus 1. All right? So there's the factors of that expression. And so what we're saying is, if you factor this form into this form, you have x plus 1, and actually times x plus 1, just rearranging these a little bit, and then x minus 4. And again, we know that this ratio cannot equal 0. The only way it can equal 0 is if the numerator is 0, and that can't happen. But we do have concerns, and we want to note that x cannot be negative 1, and x cannot be 4. So on our number line, we know negative 1 would not be allowed, and 4 would not be allowed. So those points cannot be included in our solution. But what they have determined is some intervals that we can now test. And for instance, right in here, between negative 1 and 4, I can check x equals 0. Well, the numerator doesn't even have an x in it, so that's just going to be a 3. And the denominator, very apparently, is going to go clearly to a minus 4, right? Because every x term is going to 0. And then that's the question you're asking. Is negative 3/4 less than 0? And yes, it certainly is. So numbers in that range, numbers in that set will work. Now, if we try a number bigger than 4, like say x equals 5, then we've got, again, we've got a numerator of 3. That's a constant. We've got a denominator of 5 cubed minus 2 times 5 squared, right? Minus 7 times 5, and minus 4. And the question is that less than 0? Well, that gives us 3 over 125 minus 50 minus 35 minus 4. Is that going to be less than 0? Well, really, it just comes down to signs. The numerator is very plainly positive. And I think it's apparent by looking at that denominator that 125 minus only 84, that's going to be a positive number. And a positive divided by a positive is positive. So can that be less than 0? That's the question. No. So numbers bigger than 4 will not work. All right. Now, if you try a number less than negative 1, for instance, negative 2, our numerator held constant at 3, and we've got negative 2 cubed minus 2 times negative 2 squared minus 7 times negative 2 minus 4. And the question is that greater than 0? So that's 3, rather, I apologize. The question is that less than 0, right? This is supposed to be less than 0. So we have negative 8 minus 8 plus 14, right? Because minus 7 times minus 2 is plus 14, minus 4. And the question is that less than 0? Well, again, your numerator is obviously a positive number. It's a 3. The denominator is minus 8 is minus 16, minus 4 is minus 20, and minus 20 plus 14 is still minus. In fact, it's minus 6. So 3 divided by minus 6, is that less than 0? Yes, it is. And so numbers below negative 1 will work. Numbers below negative 1 will work. So there's a visual of our solution. And now all we need to do is map this to our number line. So I go around negative 1, and I click that, and I do not want to include negative 1, so I make it an open circle. And I'm also concerned about 4, so I go over here to 4, try to spot that up. And then if I pick that as an open circle, and now go to my draw tool, and I want numbers below negative 1, so I click in there, and I want numbers from negative 1 to 4, so I click in there, and you submit your answer in that way. So that's question number 12. We had a lot of questions about that. The factoring it was a difficult thing for people to do. And then beyond the factoring, you determine intervals because of the denominator going to 0, and then you have to test those intervals. Right? So that's a solution for number 12. We'll get rid of this number 12 material, and we'll move on to number 13 and 14 right behind it. And in this situation, um, this should be fairly quick. We've got x plus 2 over 9 minus x squared, and I consider it equal to 0. And right away, I hope you see x cannot be 3 and x cannot be negative 3. So those are going to be two numbers I'm focused on. And in terms of the numerator can be equal to 0 if x is negative 2. Right? So if x plus 2 equals 0, then that gives me x equals negative 2. focus numbers. I take the numbers I'm concerned about, put them in numerical order on my number line. So I've got minus 3 to the far left, and then I've got minus 2, and then over here on the right, I've got 3. Okay, and even though this is greater than or equal to, right? We got the or equal to symbol in there. Um, I'm going to allow the negative 2 because that will make it equal 0. So I include that point. But the two threes must be left out. They're a result of the denominator being 0 and so cannot be included in our solution set. Finally, we go to testing intervals. And again, it's about the sign because we want to know when this thing is greater than or equal to 0. So if we test a number like 4, then we get 4 plus 2, and I know that's positive, and the denominator is 9 minus 4 squared. And the question is that greater than or equal to 0? Well, is 6 over negative 7 greater than or equal to 0? Clearly not. It's a negative number, right? So in a lot of cases, you don't have to do the actual computations. As long as you know the plus or minus of the thing because you're set to 0, it's pretty obvious. So negative 6/7 is not greater than 0. And so that region is going to be a no, and you're not going to shade that region. Now in here, we have a very good test number. We have 0 to test with. And so we have 0 plus 2 over 9 minus what is basically 0, right? And is that greater than or equal to 0? Well, the top is clearly 2. The bottom is plainly 9. 9 2/9 is clearly greater than 0. Those numbers will work. Numbers from minus 2 to 3 will work. Now, in the region from minus 3 to minus 2, here you're going to have to go to a decimal or a fraction. And I'm going to use negative 2 and 5/10. All right. Well, again, watch the SIGN. Watch whether it's plus or minus. Minus 2.5, right? That's the number I'm testing. Plus 2. Okay. So that numerator is clearly going to be a negative number, right? Negative 2.5. You only add 2. That's going to remain negative, right? The denominator is going to be 9 minus a number that's absolutely less than 3 that you're going to square. Now, if you want to do all the arithmetic, you can. That's going to be 9 minus 6 1/4, right? Negative 2.5 times negative 2.5 is negative 6 1/4. And more importantly, 9 minus only 6 1/4, that's going to result in a positive number, right? I can get the exact value if you want it, right? 2 and 75 hundredths if you want the exact value. Negative 1/2 on the top if you want the exact value. But if you just look at the signs, right? We got a negative divided by a positive. Can that be greater than 0? That's the question, right? The answer is no. It cannot be greater than 0. So numbers in that region do not work. That region is a no. You're not going to include that as part of your solution. Okay? And finally, a number below negative 3, we plug it in the original inequality, and we use like negative 4 plus 2 over 9 minus negative 4 squared. Is it greater than or equal to 0? Well, if you look at it, the numerator is plainly negative. Negative 4 plus 2, that's going to be a negative number, right? And on the bottom, when you square the negative 4, you're going to get 16. And 9 minus 16 is also going to be a negative number. So you do have to do the arithmetic. And if you're more comfortable doing the arithmetic and getting the actual values, it would be negative 2 over negative 7. And is that greater than or equal to 0? Well, a negative divided by a negative is a positive. So that interval's a yes. And those numbers will work, right? So we're just picking numbers from intervals and testing them, and that's telling us everything about that whole interval that we determined from either being equal to 0 or being undefined. We'll then go to our virtual tools, okay? And if you're having trouble seeing the virtual tools, some people have mentioned they are. It's typically, if you, your browser, if you just get a good browser. Now the -3 is not included, so I use that as an open circle. The -2 is included, so when I click on that, I leave that as a closed in circle. And then the number 3 itself up here, I spot that and I click that to an open circle because it can't be a 3. And now you grab your pencil, and to shade this, I want numbers below -3, so I click there. And I want numbers between -2 and +3, so I click there. And there's your solution um, to question number 13. And we hope you're getting the idea behind testing these intervals. All right, one more to go, and that's going to be question 14. Very similar to question number 13. And we've got an x minus 3 and a denominator of 2x plus 1. And this time less than or equal to 0. Okay. And again, just think of it as equality for a minute. If you're having trouble with these inequalities, just think of it as equality, right? Fairly obvious. A fraction can be equal to 0 when x is 3. So x equals 3 is going to be one number I'm concerned about. And then a denominator with a variable. Can that go to 0? Right? Well, yes, it can, because if 2x is equal to -1, then x is equal to -1/2. All right? And so we would exclude x being -1/2. That would not be allowed. It would be out of our domain. We then go to a number line, and we're going to be doing the same sign checks. Now I want to get them in numerical order. Make sure you get them in numerical order. So the -1/2 is going to be to the left, and the 3 is going to be to the right. Okay. Um, Now from there, we're going to test in the original inequality. I'll try this middle interval first, and I'll try 0. So I've got 0 minus 3. That's plainly going to be negative. And on the bottom, I've got 2 times 0 and plus 1. And that's plainly going to be positive. Now, is that going to be less than or equal to 0? Top, -3. Bottom, 1. Is that less than or equal to 0? Right? Well, that's true. Yes, it is. Right? -3 is less than 0. So those numbers in here, all the way from -1/2 to 3, are going to work. And I shade those in. All right? Now, number bigger than 3. Let's say x equals 4. Right? We plug in the 4 for the x. We have 4 minus 3 over 2 times 4 plus 1. Is that going to be negative? That's what you're asking. Is 1 over 9 less than or equal to 0? And the answer is no, it's not. So numbers in that interval do not work. All right. And finally, a number less than -1/2, maybe a -1. We have -1 minus 3 over 2 times -1 plus 1. Is it less than or equal to 0? So we got -4. So your numerator is negative. Okay. That doesn't tell us everything. We need to know what the denominator is as well. And in the denominator, 2 times -1 is -2, plus 1 is -1. And what's a negative divided by a negative? Negative divided by a negative is a positive. Okay? So is 4 less than or equal to 0? Again, that would be a no. And that interval would be out. We take the information, we go to our virtual tool, we go to our number line. We're interested, remember, in -1/2 and 3. I have to kind of locate, I have to spot the -1/2. It's right there. Um, Remember, the -1/2 cannot be included. Okay, so I leave that as an open circle, right? Leaving this open. And then I spot up here at 3. And the 3, should I fill that in? Should I leave that filled in? Or should I spot it to open? The 3 was caused by it being equal to 0, right? And so right here is where we got that from. We got that by setting the numerator equal to 0. Equality is allowed, and so that number is good. That's a shaded position on that number line, right? And now finally back to my virtual tools here. I click the shade tool. I want the numbers from -1/2 to 3. You click in there, and that provides your solution. So those are questions 11 through 14. No doubt there were some difficult ones in there. And if you need more help with these exercises, if there's something that isn't clear to you or you're not understanding, please don't hesitate to get back to us. And everything we can work to try to explain it to you. Um, we'll see you later.